couple sections that we're going to be looking at. This diagram here actually comes really in handy of being able to see and visualize what is happening. So this should look very familiar in terms of having parallel lines and two transversal lines going through it. Transversal lines just means lines that cut through, transverse between them. And then we have a whole series of angles that are then formed, from complementary angles, corresponding angles, and alternate interior angles, alternate exterior angles, okay, supplementary, linear, etc., etc., etc. All those angles here that combined. But what's going to start happening is to recognize which angles are congruent and which angles are a sum of two other angles. So let's say we start off with our yellow and we say, okay, this angle here, we don't know what it is, and we don't really care, because even if I was to widen these, shrink these, or anything like that, those angles will technically still be an angle there and exist. And all of these would move correspondingly. They would all move in accordance with however I did it. So if I happen to say that one there is a yellow angle, then I can start going through and trying to see which other ones happen to be yellow. Well, based off of vertical, then this one would be yellow. Okay, and so then let's pick a different color because we don't know any of the rest of these angles. So let's go with red. And what I'd like you to do is draw it out yourself and start shading it in as we go along. What that'll allow us to do is to be able to get an idea of these are the congruent angles, and they're always going to be congruent in this type of a situation. So just go ahead and shade those in yellow. And let's pick red. So that angle just happens to be red. I don't know what it is, I don't care. But what I do know is that because of corresponding angles, that if I take this and move it all the way down, this angle here would also be red. Okay. And so then what I get is, okay, what else is red? Vertical angle says this one's red. Alright, well, I don't know what other ones I can do. So I'm going to try blue. Let's switch over to blue. And we are going to do this one down here, blue. So if that one is blue, vertical angle says this one is blue. Okay. Which also corresponding angles says this one is blue. Alternate interior angles says this one is blue. And we actually have a red alternate interior angle here, or vertical angle here. Oops. So, pretty cool so far. So all of these are red, are congruent, and will always be congruent in this type of setup. It doesn't matter. The ones that are blue would always be congruent in this type of setup and never matter. So what about these ones that were down here? Well, according to corresponding angles, this angle here and this entire angle here have to be congruent. And so this actually is composed of both yellow and green angle added together to give you this one here. So we're going to use green because we have yellow and blue that's added together to get that one. So if that one's green, then vertical angle says that one's green. So about over here, this entire angle here is a mix of yellow and red. So that means this is basically the color orange. And so now we've found all of the angles. It does not matter what degrees these technically are given. When they're all said and done, everything that is red would be congruent. All the angles that are yellow would be congruent. All that are blue would be congruent. Everything that's orange would be the sum, or the act of adding the red and yellow degrees together, so however much that one is, and however much this one is, because that would be an alternate interior to this guy. And green would be the same amount as you'd get if add the yellow and the blue together over here. So what's going to happen is that we'll start noticing things in here to come up with our next couple theorems. And the one thing to notice, if you look at just this triangle here, so if we were just to look at that triangle there and ignore everything else, if we happen to erase it, what you would see is that the triangle here is made up of our three primary colors of red, blue, and yellow. And those add up, no matter what, however I move those, to equal that sum of that triangle. Okay? Well, what else do we notice here? That we have yellow, red, and blue. If I come and look up here, red, yellow, and blue form a straight line. Okay, so a straight line, as far as we know, has 180 degrees. So if these add up to equal a straight line, which is 180 degrees, then what does that tell us about the sum of the degrees in this triangle? It is also 180 degrees. So this is what's called the Triangle Sum Theorem, which says every single triangle you can ever take, because of this concept here, you can break off any of its corners and stick the corners together, and they will form a straight line or 180 degrees. So that is one of the biggies that we want to make sure that you get down and have, is the Triangle Sum Theorem. And so that would be in your notes. You want to make sure you get that down. Find it in your glossary, start, highlight it. Every triangle has 180 degrees in it. Yellow, red, blue, yellow, red, blue, straight line, 180 degrees. So that's the one thing to pay attention to this diagram. The next one that we're going to be looking at is called it's about exterior angles. Okay? And the exterior angle is a relationship between this angle here and this triangle. So what we can look at is that if we were to erase all the rest of this stuff, and let's just look at these for now. And so all I'm doing is just removing some of the other visual stuff that could be in the way. Still there, but just erasing it for now. This is the diagram you'd be left with. You have a triangle that has 180 degrees, but then also you have this straight line and this exterior angle that is outside of the triangle. And this really neat, interesting concept happens. If you notice, what color is that exterior angle? And how is that color related to yellow and blue? What do you have to do to yellow and blue to create green? You're absolutely correct. You have to add them together. And so whatever measure this angle is, these two remote interior angles will add up to equal this exterior angle, because together they form 180 degrees. So what that means is that if I had another little triangle here, and I said this angle here was 60, and this angle here was 70, can I find x? The answer is yes, and you can do this one of two ways. You can either say, well, all these added up to equal 180 because that's the triangle sum conjecture, or you can also say, well, this angle here must add up to equal 70 plus x, and together they all add up to equal 180 degrees. So 70 plus 60 is 130, subtracted from 180. So x equals 50. And so these two are like sibling concepts between the degrees in a triangle add up to 180. This line out here equals to 180. But that this angle here is made up of these two over here. So on that though, and let's see if this plays true on my other side.
Over here. See? Then I need the car.
If we look over here, I have my straight line of 180 degrees, and I have the color orange. Well, how does orange compare to yellow and red? They have to be added together to get this here. This is the basis of the exterior angle, is that this angle here is the sum of these two angles here. These are called remote interior angles because they're far away from this guy here, and vice versa ditto. Right? And all of that still comes back to this initial triangle. So if you have this copied down and colored down, you have the Triangle Sum Theorem, you have remote interior angles, you have the Exterior Angle Theorems, everything, alternate interiors, corresponding, etc., vertical, they're all wrapped up in this one little diagram. And a great visual of how those things are all connected. So as we go into our next section of the exterior angles in the Triangle Sum Theorem, I hope this video helps visual and obviously your own colored diagram to be able to see how they are all related and the concepts behind them. I hope this helps.